Greetings to you all, my friend. Welcome back to the science family. Today you are going to revise repeated question of a Senior 3 Physics National Examination. Please take your notebook, pay attention, and if you get any question, please type in comment. And if you know any candidate in a Senior 3 or ordinary level, please share to them because it helps them to pass national examination of 2026. These videos containing three sections. Section A containing repeated question in Section A from a national examination past paper. And also we have Section B containing repeated question in Section B from national examination. And also we have Section C containing repeated question of Section C from national examination. Let's start. Section A. Question 1. The brick shown in the diagram, figure 4, is being pushed by a force on a smooth and horizontal table. We have table surface, we have pushing force and box. A. The pushing force does not make the brick move. Explain why. I. The brick does not move rightwards. I2. Weight of a brick does not make it move downwards. This question, it comes from National Examination of 2024 and the National Examination of 2018 and the National Examination of 2025. This question comes from the unit called friction. Make sure that before national examination you cover or you understand where the topics called friction force. The reason why the brick does not move rightwards because the pushing force, this pushing force is less than friction force. You know that a friction force is the opposition or opposite to the motion of an object. Means that if this pushing force is less than the opposing force, correct friction force, this box don't move. Or if the pushing force is equal to the friction force or opposing force, means that this box not move. This is a more correction or more answers. I2, weight of brick does not make it move downward. Why this box not move downward? The reason why this brick of weight does not make it move downward because the balance of weight of brick and reaction force. Weight of brick and reaction force. This weight of brick is equal to the friction force or is a balance. That is why this box don't move downward. Let's continue by question 2. In one national examination, you see friction force asking like that, and also in this way on the question 2. A force of 400 Newton is applied to a 40 kilogram object moving on horizontal surface of which the friction force is 200 Newton. A. Found the net force acting on this body. B. Found acceleration of moving object. You know that the net force is the total force, means that you take this force plus this force. And also you know that a friction force is opposite force, means that friction force it gets negative sign. That is why you see that a net force or is equal to this force applied negative friction force because it is opposite force, it gives a negative sign. That is why we get 400 Newton, negative 200 Newton, we get 200 Newton. B. Found the acceleration of a moving object from or by using the second Newton's law of motion states that a force is equal to the mass times acceleration, means that acceleration is equal to the force over mass. We use this formula. The force we use is net force, 200 Newton, and the mass we use 400 kilogram. We get 5 meter per second squared. And also another question that repeated in section A in every national examination is a motion. For example, this question 3. A vehicle having rectilinear motion is moving with a velocity of 10 meters per second and accelerates uniformly to the 15 meters per second over a distance of 225 meters. A. What is its acceleration? Is it I? Is it I2? Is it I3? Is it I4? B. What will be the time taken to cover this distance? Is it I? Is it I2? Is it I3? Is it I4? This equation of motion, it comes from a national examination of 2024 and also in national examination of 2021, and also it comes from national examination of 2015. This unit of motion maybe it can be a formula, for example, like this question, or it can be a true or false, or it can be a multiple choice. Make sure that before national examination you cover the unit of motion, or rectilinear motion, or linear motion, or qualitative linear motion. Make sure that you know the formula or definition of distance, speed, velocity, acceleration, and also you know the graph, and also you understand where its standard unit. As you see, we have a data given velocity. This is the initial velocity equal to the 10 meters per second, and also this is the final velocity equal to the 15 meters per second, and also this is a distance equal to the 125 meters. This is a data given and asked acceleration and time taken. As you know, in qualitative linear motion, we have three formulas. We have first formula, final velocity equal to the initial velocity plus acceleration times time. Second formula we have is a displacement equal to the initial velocity times time plus 1/2 times acceleration times time squared. Third formula we have final velocity squared equal to the initial velocity squared plus 2 times acceleration times displacement. From these three formulas, according to the data given, we are going to use the last one to search acceleration. We are going to use a final velocity squared equal to the initial velocity squared plus acceleration times plus 2 times acceleration times displacement or the distance. Because we use this formula because in data given we don't have a time. We have a final velocity, we have initial velocity, and we have the distance. That is why we are going to use this formula to search this acceleration. By step, you see that acceleration we get a final velocity squared negative initial velocity squared over 2 times distance. You see these steps. The final velocity, the final solution of acceleration, we see that we get 0.5 meters per second squared. That is why this option 3 is correct. And don't forget to add SI unit, meter per second square, as the SI unit of acceleration. V square is final velocity, ut is initial velocity, x is distance, a is acceleration. B, what will be the time taken to cover this distance? The time taken to cover distance we can use The first formulas, as I said, final velocity is equal to the initial velocity plus acceleration times time, as you see here. Final velocity is equal to the initial velocity plus acceleration times time. We do step by step and search this time. As you see, we get a time is equal to the final velocity negative initial velocity over acceleration. We use final velocity, we have equal to the 15 and initial velocity equal to the 10, and the acceleration we calculate here. You see that we get time equal to the 10 second. Don't forget to add SI unit and do step by step in order to get more marks. Means that option IV is the correct. In a few, this is a question that more repeated in national examination, and also we see that in a section A, and also we have a unit called energy conservation, and also heat, temperature, and also Archimedes principle or Pascal principles. These units repeated more in section A by using multiple choice, by using true or false, and by using definition, by using equation, and so on. Make sure you cover these unit before national examination. Let's continue by section B. In section B, question 4, when a light passes through a lens, it is reflected at both faces of the lens. A. Copy the diagram, figure 7, into your answer booklet and complete the path of light ray through the section of lens. Include the normal line at both faces. You see that we have ray of light or incident ray. We have these face, we have face, first face and second face in the medium of air. B. Draw ray diagram to show the formation of virtual image in a converging lens. C. A converging lens of focal length 25 cm and diverging lens of focal length negative 10 cm are placed in contact. I1. Calculate the power of converging lens, the power of diverging lens, the power of a combination of these lens. I2 is the system formed by these combination of lens, converging or diverging. Explain your answer by ignoring the lens thickness. This question 4 of lens and ray diagrams, it comes from 2024, 2028, and 2011. Make sure that before national examination, make sure you understand the lens, converging and diverging, and the ray diagram, and also the mirrors, understand where about mirrors, understand where about converging and diverging lens, and understand where about ray diagram. The first question, copy this diagram. We copy this diagram as you see and complete the path of light ray through the section of lens. The first you can see is refracted, refraction means that the light ray bends to the medium, from one medium to the another. Means that this incident ray to the first face and formulate a normal, and then this light bends in this medium near to the normal and stick to the second face, and then emergent ray of light bends away from normal. You see. B. Draw ray diagram to show the formation of virtual image in converging rays. In order to get virtual image, you must put object between optical center and focal point. And using three ways, the first, the ray pass to optical centers it back itself. And also we use the light ray pass to the. On question B, in order to get a virtual image, you must put object between optical center and focal point and use all instruction and three ways to make image. C. Converging rays of focal point 25 cm, diverging rays of focal point negative 10 cm placed in contact. Calculate power of converging rays. The power of length is equal to the 1 over focal length. Means that the power of converging rays is equal to the 1 over 25 cm. And the power of diverging rays is equal to the 1 over negative 10 cm. And the power of combination of rays is equal to the total of power. Means that is equal to the power of converging rays plus power of diverging rays. And according to the sign we get in a power of combination of these rays, it helps to get the solution on either converging or diverging. If you get the positive sign on a power of combination of these rays, means that is converging rays. But if you get a negative sign of a power of combination of these rays, means that is diverging, because the focal length of diverging is negative always. You see here on the power of converging, you see we have 4 per meter or diopter. This is the SI unit. The second diverging, power of diverging, we get negative 10 per meter. And also total power or power combination, we get power 1 of converging and power 2 of diverging. We get negative 6 per meter, means that this combination of rays is diverging. The system formed by this combination of rays is diverging because the total power of a system is negative. So its focal length is negative. Let's continue to another repeated question in section B. As a question 5, Archimedes' principle stated that a body immersed in a fluid experiences upward thrust or buoyant force and is fundamental to be equilibrium of a body floating in motionless water. A. Consider a massless balloon filled with 10 power negative 3 meter cube or 1,000 centimeter cube of water in a container of water as shown in figure 8. The distance of water is 1,000 kilogram per meter cube, and acceleration due to gravity equal to the 9.81 meter per second square. As you see in these figures, you see this balloon is full immersed in this fluid. A. What is the volume of water displaced by balloon? To show that the weight of water displaced in a container is 9.81 Newton. 3. What is the buoyant force acting on the balloon? The figure shown that the body floats completely submerged just below the surface of the liquid without rising or sinking. Explain your answer. This question of Archimedes, it comes from a national examination of 2024, national examination of 2021, national examination of 2017. And also this unit of Archimedes principle, it comes repeated in section A as a multiple choice, as a true or false, and definition and states. Make sure you know these unit, Archimedes principle and Pascal principle, before national examination. According to the question, as you know, the Archimedes principles, it is stated that when a body is totally or partially immersed in a fluid, it experiences an upthrust force or buoyant force equal to the weight of fluid displaced. That is a Archimedes principle. And also we have a formula where the upthrust force or buoyant force equal to the weight in air, negative weight in fluid. And also we have another formula where the upthrust force or buoyant force is equal to the density of a fluid times gravity or acceleration due to gravity times a volume of fluid. According to that theories, we are going to answer the question, what is the volume of water displaced by balloon? The volume of water displaced by balloon is equal to the volume of fluids, as you see in correction. Volume of displaced water is equal to the 1000 centimeter cube, and put this unit into standard unit of volume. That is why we take this in centimeter cube, change into in meter cube. Always don't forget to change the unit into standard units. And also, I2 show weight of water displaced is contained in the container is 9.81 Newton. In order to see the weight of water displaced, we are going to use the formula of buoyant force. You understand where the buoyant force or upthrust force is equal to the weight of displaced fluid. That is why we are going to use the formula of buoyant or upthrust force, where the density of fluid times acceleration due to gravity times volume is equal to the weight of displaced or is equal to the buoyant force, as you see in a solution. Density times volume times gravity. You see that we get 9.81 in Newton. B. Assume a balloon is placed by a 0.5 kilogram piece of wood that has exactly the same volume, 1000 centimeter cube or 10 power negative 3 meter cube, as shown in figure 9. You see, this is a volume, this is a wood. I1. What is the buoyant force acting on the piece of wood just after it was raised? What is the buoyant force? And also, you can use the formula. You can use the formula of density of fluid times acceleration due to gravity times volume. We have a volume, we have density of water is equal to the 1000, and also we have a gravity is equal to the 9.8. We get also 9.81 Newton. As you see here. And also I2. What is the weight of a piece of wood in the air? As you know, a weight is equal to the mass times gravity. The weight of piece of wood in the air means that we get mass of wood times gravity. We get this mass times gravity or acceleration due to gravity equal to the 9.81. You see that we get 0.5 times 9.81 Newton, we get 4.9905 Newton. I3, just after releasing the piece of wood, with the piece wood float partially immersed in water. Float completely submerged just below the surface water or sink. Explain your answer. This piece of wood will float partially immersed into water because the buoyant force is greater than its weight, or upthrust or buoyant force is greater than the weight in air, according to the laws of excitation. Make sure that the theories, the unit of Archimedes principle, atmospheric pressure, and the Pascal principle you understand well before national examination. Let's continue to the next question, repeated more and more in the national examination. Is the unit, it comes from the unit of electricity. In this unit of electricity, make sure you understand well Ohm's law, statement, and application. Make sure you understand electric power formula. Make sure you understand electric energy and factors affected. Make sure you understand parallel circuit or series circuit. You know equivalent resistance and currents. And also make sure you understand circuit device, fuse, vase, circuit break, because this unit is repeated in every national examination. Either Ohm's law, either electric power, either electric energy, either parallel circuit or series circuit, or either circuit device. Make sure you understand these units well. For this question, question 6, you are provided with the following components of electric circuit, namely connecting wires, 1 ammeter, 1 voltmeter, 1 resistor, and 1 resistor, 2 dry cell, and 1 switch plug key. Design a laboratory experiment to verify Ohm's law. In your designer, you should consider the following step. A. Draw an electric circuit diagram showing the arrangement of giving a laboratory material. B. State procedures to be followed and the measurement to be taken. C. Analyze the data collected during the measurement. D. State at risk to surface application to be taken during experiment. This question, it comes from Ohm's law practicals. It comes from National Examination of 2024, National Examination of 2020, National Examination of 2021, and also National Examination of 2016. Make sure you understand this unit. According to the question, first you draw. According to the question and the theories we know in this unit, ammeter, 1 resistor, 1 resistor, 2 dry set, and 1 switch connect in series, and 1 ferrometer connect in parallel, as you see in solution. Electric circuit diagram, you see this is a resistance, you see this is a switch, you see this is a dry cell, this is a resistor and ammeter. You see this one is connected in series, and you see this is a voltmeter. This is connected in parallel. This is a different procedures to be followed and the measurement to be taken. You read slow by slow. And also this is a application or a connection must be very tight. You read this one slow and slow. Question 7. A circuit consists of 60 ohm and 30 ohm in a parallel arrangement, a resistance of electromotive force 3 volt, and a negligible internal resistance is connected across the whole circuit as shown in figure 6. You see. A. Analyze the given circuit and then found I. The equivalent resistance of this parallel network. I2. The total electric current in circuit. I3. The electric current through the 60 ohm resistor. I4. The electric current I2 through the 16 resistor. B. Compare the total electric circuit and individual electric circuit in the 2 parallel branch. Conclude. According to the equation, equivalent resistance of this resistor connected in parallel is equal to the 1 of resistance 1 plus 1 of resistance 2 because it is connected in parallel. I2, the total electric current. The total electric current In this circuit, we use the formula of electromotive force equal to the current times internal resistance plus current times external resistance. As you see here, the internal resistance is negligible, meaning that electromotive force in the formula is equal to the current times external resistance. That is why current is equal to the, as you see here, is equal to the electromotive force times resistance external. Electromotive force over external resistance. You see the difference. And the formula you can use to calculate the current one, we use this formula. We use electromotive force over resistance. If we calculate the current one, means that we use electromotive force over resistance 1. If you calculate resistance current 2, we use electromotive force over resistance 2. You see here in 60 ohm is a mistake, is 30 ohm resistor. You see that. This is a solution. B. Compare the total electric circuit and individual electric currents in the two parallel branches. Conclude. This is the solution. Total current is greater than individual current. As you see, as resistance R1 and R2 are connected in parallel, the total current in a circuit is equal to the sum of individual current in each branch. As you know, the law of induction, entering current is equal to the leaving current. Current equal to the current 1 plus current 2. Let's continue to the next question, repeated more in national examination. Differentiate between heat capacity and specific heat capacity. B. Describe how the following mode heat transfer takes place: conduction of heat, convection of heat, radiation of heat. C. Vacuum flask has 5 elaborate features, each one designed to reduce heat transfer. Analyze figure 5 shown above and answer the sub-question below. You see, this is a vacuum flask. This is a small feature of its part. We have this one is metal container, cork support, silver inner surface, double-walled glass container, and vacuum. I. Which elaborate feature of vacuum flask reduced heat transfer by both conduction and convection? I2. Explain how this feature of vacuum flask reduces heat transfer by both conduction and convection. I3. Which elaborate feature of vacuum flask reduces heat transfer by radiation? I4. Explain how this feature of vacuum flask reduces heat transfer by radiation. This is more. This is a more correction of that question. This is a difference between specific heat capacity and heat capacity. If you differentiate some quantities, you can use definition, as you see definition of specific heat capacity and definition of heat capacity. And also you can use the SI units of specific heat capacity and use SI unit of heat capacity. And also you can use the formula of specific heat capacity and formula of heat capacity. If you use one, you use the definition only, you get low marks. If you use definition as a unit and formulas, you get full marks. The next, this is a definition of conduction heat. This is the definition of convection heat. Conduction heat is a process in which heat is transferred from hot part of cold to the cold part in the solid body, from one molecule to another molecule as a result of vibration motion of molecules. Convection heat is a process of heat transfer in liquid and gas from region of higher temperature to the region of lower temperature due to actual movement of molecules or due to mass transfer. I3. Radiation of heat is a process in which heat is transferred from one body to another without involving the molecules or medium. Question C. The vacuum flask has elaborated this one. Which elaborate feature of vacuum flask reduces the heat transfer? Is this one? Vacuum. Explain how the feature of vacuum flask reduces heat transfer. You see, this is the correction. Lack of atoms. Without atoms, you estimate conduction and conversion of heat. The next question is river inner surface and it reflects radiation. And also in this unit, we see that we have question 9, thermal expansion intended of a matter of change in shape, volume, area in response to change in temperature. The rise in temperature of substance depends on the amount of heat transferred to it and its nature and its mass. These units for the question 8 and the question 9, it comes from the national examination of 2024, 2020, and the 2013 in section B. Make sure you understand where these unit of specific heat capacity, unit of heat and temperature, unit of heat capacity. Make sure you understand where. Make sure you understand to differentiate specific heat capacity and heat capacity Make sure you know how you use the formulas to calculate any question. Make sure you know to differentiate conduction, convection, and radiation. You see this question 9, thermal expansion. Question A, I identify the general mode of heat transfer in solid. I2, identify the general mode in heat transfer in liquid. B, differentiate the heat and temperature. C, temperature of a nylon block of 2 cm long, 10 cm wide, and 5 cm higher is raised from 10 cm to the 10 degrees Celsius to the 14 degrees Celsius. The coefficient of linear expansion is equal to this. Found the physical quantity below. I, initial volume of iron block. I2, coefficient of volume expansion of iron block. I3, changing volume of this iron block. IV, final volume of mentioned iron block. This is the correction. I, the general mode of heat transfer in solid is conduction, general mode of heat transfer in a liquid is convection, and also general mode of heat transfer in a gas is correct radiation. This is a thermal difference between heat and temperature. More you write many weights or many quantities used to compare heat and the temperature, more you get more marks. You see that? You read this one slow by slow. This is the correction of number C. Initial volume, use length times width times height. You see the coefficient of volume or expansion, use this formula. You see the change in volume, you use this formula and you get the final volume, you use this formula, and this is NB. The candidate maybe also use this formula for final temperature. Let's continue by section C. Before we go, make sure you understand this unit, heat and temperature, specific heat capacity and heat capacity. You understand conduction, convection, and radiation before you enter in national examination. Let's continue in section C. Many times in section C, the repeated question is graph, plot graph. Please make sure you understand where to plot graph. For example, in section C of National Examination of 2019 is plot graph of current against resistance. In the National Examination of 2024 is a plot graph of pressure against heat. In National Examination of 2021 is a plot graph of temperature against time. Make sure that you know how to plot graph well. Section C, it have 15 marks. If you know how to plot or to draw a graph perfectly, you get your 15 marks. Let's continue. Question 10. In experiment to investigate the relationship between force on an object and acceleration it experiences, a runner used the following experiment setup shown in figure 10. This one. He or she recorded the reading in a table below, force and acceleration. This is a data we use to plot. A. Identify the measuring instrument to measure the following physical quantities. I. The measuring instrument used to measure mass is what? I2. Instrument used to measure distance is what? B. Provide the formula used to determine acceleration of card. Justify your answer. C. Plot graph of force applied to the body against acceleration. You can draw best fit line on graph paper. D. What does your graph tell you about relationship between acceleration of body and force applied to it? Support your answer. Determine slope your graph. Identify your result. A. On real runner of this experiment, a runner found that the graph did not go through the all plot point. Suggest any one based on 4 base. This is the correction of that question. The instrument used to measure mass is balance or beam balance. It may be beam balance or spring balance. I2. Instrument used to measure distance is the meter, and so on. The formula is this. Distance is equal to 1 over 2 acceleration times time squared. Graph. In order to plot graph, make sure you labeled 2 axes. Make sure you labeled use 2 uniform scale. Make sure you plotted well point. Make sure you join or you get best fit straight line as you see here. If we say that a graph of force against acceleration means that this force is in y-axis, you write force in y-axis with its SI unit, and and acceleration in the x-axis with its SI units, and also show where the origin be. And also make sure you scale equal intervals or equal scale, uniform scale. In this we have 2, 1, 2, 1, 2, and also in 0.20, 0.2, 0.4, 0.6, 0.8, and also 1. You see that we have intervals of 0.2 in both. Before you put all points, you also make sure all points is plotted well by joining y and x axis, and also draw the best line. As you see, this is a straight line. These points are joined well, but these points is not any plotted line or is not any best line fit. The reason why is due to the parallax error or reaction time or random error and a predicted change during experiment. This don't accept error. It may be systematic error or random error. Do you understand? And also how to calculate or to define a slope. You can use a slope. You know that the formula of slope is equal to the change in y-axis over change in x-axis according to the diagram or graph. Means that the slope, you can take this point, this one and this one. Means that the slope is here. I'm going to use here. Means that the slope is equal to the change in y-axis. Means that is 0.20 and 0.2 divided by change in x-axis 0.4 and 0.20. The value you get is the slope of that graph. if you draw this graph perfectly, you see that this slope, even if you take this point or this point, you get the same answer of slope. Thank you so much for your attention. If you like these videos, please make subscribe for another videos on the time, and also don't forget to share these videos to the candidate you know, to the student of Senior 3, in order to pass well the National Examination of Physics 2026. And also, if you get any question in this video, please type in a comment. And also, don't forget to tell me what you want in the next video. Thank you so much. Bonne chance in your every activities. Thank you.